So I'm going to do a few practice exercises with all of the thread inspection tools from start to finish. If you already watched the training video, because of my limitations with parts, I'm not going to be showing you really anything that I haven't shown you already, but I'll do it again very quickly, try to show you a few techniques as I go through. If you haven't already, visit the Pragmatic Metrology website where you can download this exercise and any prints for threads on the angle block that you might need, although we don't necessarily need a print just to check for one hole. But you can also 3D print from CAD files that I have up on the website, or you can make this part yourself if you want to. But either way, just grab something that you have thread gauges for and tooling for, and use that for your practice exercise. So we're gonna use all this equipment here, and essentially we're just going to use every tool, practice using every tool. So I'm going to go through that on the before I jump into that, we're going to practice using every tool, and you can download this worksheet to write down some of your data. So you can write down what diameter, pitch, form, class, go or no go, whether you use that gauge or not, and whether they worked or not. You put like a check mark, it worked, and a cross out if it worked and it shouldn't have, for a pass or fail. If you're going to do a pitch micrometer with measurement over wires over pitch mic, you can do that for each diameter you're measuring, if it's an external. And we're going to identify some bolts and some nuts. You can write down those there as you practice. So we'll take a quick look at our print just to review. It's a 3/8 16 UNC 2B, and it's supposed to be through all, but we'll be working with a variety of parts, so I'll show you that all at once. So let's start off with the plug gauge. So you should have a calibrated plug gauge. As I said, they don't go out of calibration very quickly. You can check them with a calibrated pitch mic, or you can have an external vendor do it, and you're just going to thread this thing as far as it will go. Hopefully it pokes out the other side as a through. As I mentioned before, there's some sort of burr in there. So the go goes mostly. I can turn this around, try from the other side, and it's starting to go, and it stops. So I think I'm pushing that burr back and forth. I probably need to deburr it, blow it out, maybe run some sort of pneumatic tool in there to clean it, but ideally our go gauge would go all the way through with such a long go gauge, but it stops. So now we'll check if the no-go works, which we don't want to work. So I'll grab the no-go side, which is usually smaller, doesn't want to start. Check the back side, doesn't want to start. So pretty good except for that burr issue. Moving on, we're going to use the ring gauge on our bolt. Here's our bolt. So I'll grab the go ring and should thread all the way on. Now, if you start to feel a little resistance, I'm starting to feel a little resistance, stop. You do not want to damage your go gauge. If you're feeling a lot of resistance, it could be you need to chase the thread. It could just be that this is a bolt that has seen a lot of use and it's no longer good, but I can see at least from the beginning, it's a pretty good thread, and then it gives me a little resistance. So you don't want to force this thing through because you'll really damage your go gauge. Let's try our no-go gauge and see how many turns we can get. So let's see. Let's count how many turns. If I bottom it out, then I mark it and go 1 turn, 2 turns, and it pops out. Popped out less than 3. So the no-go is, the thread is working as intended. I may have, when I was grinding it down, I may have put a lead in on it, but otherwise, that's how you use a go and a no-go. The go should thread on, the no-go should not. It's very simple check. Need them calibrated, and you need a sticker for calibration, usually from an outside lab. If you have set plugs, you can thread. I've got the no-go and I've got the no-go thread set plug, and you can thread that on and adjust how well it's seated. You're looking for a certain amount of looseness, but also, or tightness, I should say, not too tight, not too loose. I don't quite have the feel for that. That's something I usually send out for calibration because I don't have the feel. But that's how you can check those. We can move on to my favorite, the thread wires. So I'm going to give this one more shot. I've already got my thread wires in this little holder. Feel free to use whatever holder you like, whether it's a rubber attachment or a grease. I've used grease a lot in my career, and I think that works fine. But I'm getting a little better with this holder, so let's give it a shot. So I'm trying to kind of register the back anvil on the 2 pins and then bring in the single pin. I almost had it and it popped out. Well, you saw that. So getting a little better with this. I think the key for doing it this way, if you are going to try to do it this way, is keep the pins kind of horizontal and then push the whole assembly in between the anvils. And as long as you start it off kind of close. Now here we go. This is a mess. Loosen it, but that's not too bad now. So got 2 on one side, I got 1 pretty much in the same location. They're a little bit off center, so I am going to have to kind of rock it into place maybe. And we'll take a look at our anvil. I'm reading at about the 17, maybe 17 and like 2/10. So I'm going to try and slide this out. Oh, maybe I have a little bit too much pressure. And we'll take a reading. I'll put it back at the 17 where I had it. So I am reading about 0.392 and 2/10, and from what I remember, that translates to what we got earlier. I've got the notes right here. So repeated the same measurement I did before. When you're using thread wires, it's just important you get that correct micrometer feel, and it should slip on and off just like a standard micrometer, whether it's on just a diameter. So it can be a little tricky, a little difficult, but that's what you're looking for, just like any time you use a micrometer. If we're going to use, I'm going to try using our pitch micrometer on this bolt and nut, but I'm going to need to identify the pitch. So I've got our metric thread gauges, and we'll use the leaf gauge. Let's try it on the 1.0. Yeah, it's way too small. Let's try it on the 1.25. Actually, we're getting closer. And let's try the 1.5. And it fits right in, pretty snug. So this is a 1.5 metric pitch. And I need to figure out the diameter, so I'm going to use my caliper in metric mode, about 9.86, 9.87. So I'm going to round that up to 10 because of the way, bolt sizes only come in discrete sizes. So it's a 10 by 1.5. And with my interchangeable anvils, I'm going to choose the metric anvils that fit a 1.5. And actually, I've already got those loaded. So out of my set here, these two identify with metric pitch from 1 to 2, or sorry, 1 to 1.5. So these are the anvils I already want. So now I can take my reading, and so we're using all of our gauges in quick, rapid succession. I'm going to register the thread on the lower anvil. I'm slowly going to bring in the upper anvil and rock it back and forth until it seats in there. I'm not able to rock it through. I'm going to open it up. Now I can. I'm going to close it. And I feel like I've got that nice slip fit that I always want. We'll take a look at our reading. And I'm at about 0.351 and say 0.3. So we need to convert that to metric. This is a standard inch micrometer. It has no metric capabilities. So we're going to convert 0.3512 times 25.4. That's the conversion from inch to millimeter. And I get 8.92. So my pitch diameter is 8.92. And for an M10 by 1.5, I looked this up before the video. Our pitch diameter minimum 8.861, maximum 8.994. I'm looking at 8.92. So we are in that range between 861 and 994. So this bolt is good bolt for us to use. And let's see, did we leave any of our gauges out in this sort of quick rapid fire video? Use the leaf gauges, the wires, the pitch mic, and the go and the no-go gauges. I think that's everything. So let's take a look at our assignment. Thread plug, thread ring, pitch micrometer, thread wires, leaf gauge, and caliper. So we've pretty much hit number 1, 2, 3, and 4. And we can do number 5 and 6 to identify a bolt and a nut. So we already used our leaf gauge to identify this bolt. It was a 1.5 pitch, so that means our nut is going to be a 1.5 pitch, but just to confirm, it's going to be hard to show you on camera, but if you ever have just a nut and no bolt to check it with, you can try to do this, but it's pretty hard. You can buy one of those thread checkers and just try it on every single one, or try to find the matching bolt. That's just the easiest way to do it. For the length, in metric mode, I'll do the length of the bolt without the head. So I'll use my depth bar. 24 millimeters, I'll call that 25 millimeters, which is roughly an inch. And for the nut length, 7.8, we'll probably round that up to 8 millimeters. Let's see what 8 millimeters is. It's almost about, it's definitely 8 millimeters. That's a common size for metric. So the bolt is a M10 by 1.5 by 25 millimeters, and the nut is an M10 by 1.5 by 8 millimeters. And that's how we would identify if we needed to purchase replacements for them. So I know it's a shorter demonstration video, but let's take a look at our discussion questions. So compare the attribute inspections, which are go and no-go, to the variable inspections, wires, pitch mics. Which do you think is more accurate? Why? What are the pros and cons of these? So if you saw me struggling with the wires and with the pitch mic, that comes down to technique and practice, and whether or not you grab the right anvils and the right wires. There's for a beginner, there's a lot of mistakes to make. Even for an advanced person who's done it a lot, there's still mistakes you can make. There's a lot less mistakes you can make with a go no-go gauge. It either goes or it doesn't, and as long as you grab the right gauges, you're making things a lot easier on yourself, and you won't make as many mistakes. So that's why go no-go gauging is so popular for threads. It's fast, it's accurate, and it's very simple. And the downside, thread rings get pretty expensive to purchase, to calibrate. Plugs are not nearly as expensive, and they're usually worth the cost if you're going to be doing a lot of internal holes. Generally speaking, they last a very long time. Like a 3/8 16, that's a very common size. You might have to replace that after 5, maybe 10 years, but if you're not using it a lot, it should last a very long time. So I prefer to use the go no-go, and I think for a lot of machine shops, they want to go that route just to eliminate any possibility of miking something wrong, reading it wrong, grabbing the wrong wires. There's a lot of potential for calculation mistakes with wires and with pitch mics. If you filled out your worksheet, have somebody take a look, make sure you're filling it out right. And I guess I want to thank you guys again for watching this training video, watching this exercise. Please check out the website for more videos like this where we talk about all the gauges, calipers, micrometers, hole inspection, surface plate, angles, and threads. And concepts that will help you choose gauges, calibrate them, and keep them in good condition and make the right choices in blueprint reading. I also want to thank the Laney College in Oakland. They provided me this part to help me demonstrate this video, and they have a great program for manual machining, CNC machining, metrology, of course, CAD design, blueprint reading, maintenance, even grinding, I believe. They have a lot of classes, certificates that people can earn. What was I going to say? Certificates, an associate's degree, and apprenticeships that you can work on. So if you're doing any of those in your career in manufacturing, you're really going to stand out from the crowd. So recommend you check them out if you're interested in learning more, getting hands-on and classroom experience. They do a great job at Laney. That's in Oakland, California, the Northern California Bay Area. Laney College, Machine Technology Department. Thank you for watching. Please check out my website for more resources and more videos, and thank you for watching.